Let us consider two bodies of masses m1 and m2 are connected over a pulley with the help of a string as shown. m1 is freely suspended in the air and m2 is on a rough inclined plane. Let us identify the forces acting on each of the body. We know that the weight of the body always acts in a downward direction. It creates a tightness which is nothing but the tension T in the wire or the string. Being the pulley is smooth, the same tension will be acting on the upper part of the wire. If the system is moving in the downward direction, if suppose M1 is moving in a downward direction, that will try to pull the body M2 from left to right. As the motion of the body on a horizontal surface is from left to right, frictional force comes into the picture which acts against the motion. Frictional force equal to mu into normal reaction, where in this case normal reaction is nothing but equal to weight of the second body itself. We can write equations of motion for each body by drawing a free body diagram. Let us imagine the first body M1. Let us identify all the forces acting on the body M1G in the downward direction, tension in the upward direction. The system is moving in the downward direction. So we can write the resultant force of M1 as M1G minus tension. We have written resultant force as M1G minus tension because resultant force is in the downward direction. Therefore, force in the downward direction has to be treated as positive and force in the upward direction shall be treated like a negative. So we can write M1A equal to M1G minus tension. Similarly, for the second body, we can draw the free body diagram like this. This is the second body M2. The forces acting on it is tension from left to right, frictional force from right to left, and the body is moving from left to right. We need not consider the vertical forces influence because the body is not having any vertical motion. So I can write here F resultant as tension minus frictional force. F resultant could be written like M2 into A basing on the Newton law. Frictional force equal to mu into normal reaction, where normal reaction equal to M2 into G. Using this, we can either calculate the tension in the wire as well as the acceleration of the system. By adding these two equations which were obtained by drawing the free body diagrams of each of them, we can get the acceleration of the system as M1 plus M2 of A. Here the negative tension and here the positive tension will cancel each other. M1G minus mu M2 and G. That implies acceleration of the system is M1 minus coefficient of friction of M2 multiplied by acceleration due to gravity on the earth divided by M1 plus M2. Even by substituting the value of this acceleration in equation number 1 or 2, we can also calculate the tension acting in the wire. This concept is called something like free body diagrams and applying the Newton laws of motion. Here we have applied it by considering the frictional force also into action.